Due to the overwhelming response that we've received about the MasterTech 50th anniversary introductions, we decided to continue this tradition by providing you with short segments featuring training tips and up-to-date service information. Stay tuned for this month's introduction, followed by the latest service information about the Chrysler LHS, 300M, Concorde, and Dodge Intrepid.
Someday, computers will replace drafting boards. Someday, technology will make it possible for engineers to simulate a collision or test a traction control system without ever leaving their desks. Someday, designers will use virtual reality to get behind the wheel of a vehicle that doesn't even exist. But at Chrysler, someday is today. A powerful new technology called CATIA has revolutionized the way we do business. CATIA stands for Computer-Aided Three-Dimensional Interactive Application. Many automakers use CATIA to one degree or another, but none have implemented it so completely as Chrysler. At Chrysler Corporation, CATIA is a seamless product pipeline fully integrating every aspect of vehicle development. The all-new 1998 Dodge Intrepid and Chrysler Concorde models represent the pinnacle of CATIA technology. The first ever paperless cars, they were created from start to finish with CATIA. Paperless means that Chrysler designers leave behind paper, pencil, and drawing board, using instead a stylus and electronic sketchpad to create vehicle concepts. CATIA makes it simple for designers to experiment, showing how early concepts will look with different paint treatments, predicting how body panels will reflect light, instantly transforming flat drawings into 3D. With CATIA, Chrysler was able to develop a pair of new V6 engines in just 24 months, a company record and an industry benchmark. CATIA's modeling abilities were instrumental in the process, allowing the Powertrain team to simulate internal workings of engines that didn't even exist outside the computer. CATIA's ability to simulate component performance allows for stress and load calculations, collision simulations, and can even create a virtual reality vehicle interior. CATIA also eliminates the need to fabricate expensive prototypes early in the development process. But when prototypes are needed, CATIA can create them faster and more efficiently than ever. CATIA reaches into vehicle manufacturing with stamping and welding analyses, computer-generated tooling and dies, and even a virtual reality walkthrough of a plant that hasn't even broken ground yet. CATIA technology also extends into the dealership. By linking CATIA to the TOPS vehicle ordering system, dealerships have access to current pricing and ordering information on a real-time basis. CATIA may also be used to create service publications, or even an interactive 3D database that could be accessed by dealership technicians directly from the service bay. But how is CATIA technology benefiting Chrysler and its dealers today? To begin with, CATIA drastically reduces the length of the product development cycle. What used to take years or months can now be done in weeks, days, even minutes. CATIA is a much more efficient process too, helping to lower development costs so that Chrysler can price products more competitively and provide customers with the best possible value. Linking platform team and suppliers together through a common database, CATIA eliminates the risk of variations in vehicle components, which results in better quality products. Virtual reality, rapid prototyping, computer-based testing and validation, the first true paperless vehicle design. While others look over the horizon and say, someday, at Chrysler, we log on to CATIA and say, today.
Some of you may remember the great Chrysler cars that carried the 300 designation with a letter at the end in the 50s and 60s that culminated in the 300L in 1965. For the 1999 model year, Chrysler is resurrecting the 300 designation and introducing a new model, the 300M. The Chrysler LHS has been redesigned for 1999, and with its many new and improved features, LHS continues to offer an outstanding combination of luxury and performance. Hello and welcome to another Master Tech. This month, we're going to focus on the new Chrysler LHS and introduce a model designation that some of you may recall from many years ago, the Chrysler 300 series, this time with an M at the end of it. In addition, throughout this video, we'll recap some of the revisions to the 1998 Dodge Intrepid and Chrysler Concorde that we first showed you in October of last year. Let's begin by taking a look at some of the features that you can expect to see under the hood. Beginning with the hood, LHS, like the Concorde, now features an aluminum hood, which is 20 pounds lighter than the steel hood used in the past. Steel hoods used on 300M and Intrepid are also lighter than before because of the enhanced inner panel structure. The secondary release mechanism is easily accessible and now yellow in color, making it more visible. Adjustable single pivot rear hinges allow for an accurate hood fit. Gas prop counterbalance supports are used on all of these vehicles. Because of the aluminum hood on the LHS and Concorde, the supports are mounted closer to the front of the vehicle to reduce stress. One of the biggest differences under the hood is the selection of engines. While the Concorde and Intrepid models have 2.7-liter or 3.2-liter engines, LHS and 300M have 3.5-liter single overhead cam V6 engines, which is standard equipment. Chrysler engineers completely redesigned the previous 3.5-liter engine, making it lighter while providing enhanced performance. Like the 2.7 and 3.2-liter engines, the 3.5-liter engine has a cast aluminum block, which is over 40 pounds lighter than the previous cast iron block. Cast-in-place cast iron cylinder liners provide durable wear resistance for long life. As you recall, the 2.7, 3.2 and 3.5-liter engines were covered thoroughly in last month's MasterTech program. Right now, let's review the features of the 3.5-liter engine. Like the 2.7 and 3.2-liter engines, the 3.5-liter engine is non-freewheeling. The pistons have small notches, or eyebrows, for valve clearance in the event a timing belt should jump 1 or 2 teeth. And the piston rings have a new design. The second ring acts as a scraper ring, and it's important to remember that they aren't interchangeable with the old design. The forged steel crankshaft uses smaller bearings for reduced friction. The new exhaust roller rocker arms are Y-shaped and use a new camshaft. The camshaft has 3 lobes per cylinder instead of the 4 lobes used on the old design. With durability in mind, head gaskets are now made of multi-layered steel. The 3.2 and 3.5-liter engines both use a 3-plenum upper intake manifold. The new composite upper intake manifold is reinforced with glass fiber for strength and heat resistance. The manifold tuning valve, or MTV, has been relocated to the front of the engine. The MTV is operated by a PCM-controlled electric motor, which replaces the electronically controlled vacuum actuator used previously. Turning to service, the new coil-on-plug ignition system uses platinum-tipped spark plugs that are less susceptible to tip erosion over time. The spark plugs used in the 3.2 and 3.5-liter engines are different from those used in the 2.7-liter engine. 3.2 and 3.5-liter plugs can be identified by their use of a gasket. When replacing a spark plug, it's important that you use the correct torque. So be sure to refer to the service manual for specifications. It's important that you use the correct torque. So be sure to refer to the service manual for specifications. Timing belts on the 3.2 and 3.5-liter engines now need to be serviced only every 105,000 miles. In other areas of the engine compartment, you'll notice the reservoir for the power steering fluid is now translucent, making it easy to check fluid level without removing the cap. And the power steering filler neck has been repositioned. Now adding power steering fluid is even easier. The new radiator uses tandem transmission oil coolers, one internal and one external. The internal component is an oil-to-coolant heat exchanger, while the external component is an oil-to-air heat exchanger. This new configuration allows for increased transmission cooling capacity. A new coolant is used that will affect service. This is a Mopar 5-year, 100,000-mile antifreeze coolant. Keep in mind this coolant shouldn't be used in combination with any other, as the new mixture will lack the correct amount of corrosion inhibitor formula, greatly reducing its effectiveness. An updated air conditioning condenser provides a greater heat transfer area for enhanced cooling performance. Redesigned dual cooling fans run faster, moving more air with less noise than that of the previous design. For the first time ever, a coolant pressure bottle and an overflow reservoir are used on the same vehicle. In fact, the coolant pressure bottle and overflow reservoir have been combined. Coolant from the pressure bottle is released into the normally empty reservoir. Once the engine cools, the coolant is returned to the system. The Powertrain Control Module, or PCM, which is also called the SBEC 3A, is located under the cruise control servo and now has a faster microprocessor and double the memory. The SBEC 3A supports the new bus, the PCI bus, which you learned about in the November MasterTech, and which we'll be discussing a little later. Speaking of which, a lower engine idle speed of 525 RPM results in reduced fuel consumption during idling. The Transmission Control Module, or TCM, which is also referred to as the ETAX 3A, is located next to the PCM and also supports the PCI bus. The battery has been relocated to the front fender well and front of the tire. If necessary, the battery positive terminal can be accessed behind the right headlight, and the battery negative terminal is on the right strut tower. The power distribution center contains micro relays and F-type cartridge fuses, which take up minimal space. This new, slightly larger PDC houses many more components than in the past. In a minute, we're going to take a look at some of the changes that have occurred under the vehicle. But before we go any further, let's try a review question. Which of the following features does not apply to the 3.5-liter engine? A, Y-shaped exhaust roller rocker arms. B, multi-layered steel head gasket. C, gasketless spark plugs. Or D, cast-in-place cast iron cylinder liners. The correct answer is C. Spark plugs used in the 3.5-liter engine can be identified by their use of a gasket. If you watched last October's MasterTech program, you know that the 42LE transaxle used with 3.2 and 3.5-liter engines has a different overall top gear ratio than the one used on 2.7-liter engines. October's program also covered some of the internal changes to all 42LE transaxles. Autostick is standard equipment on the 300M and Intrepid ES. The Autostick feature allows drivers the option of manual upshifts and downshifts. The TCM on these vehicles has been refined to provide crisp shifts and allow the engine to rev higher to provide maximum acceleration. However, once the engine reaches the rev limit, the TCM will override the Autostick feature and automatically force an upshift. Communication between the TCM and PCM has been improved to provide better shift quality. For example, during coast-down shifts, the PCM interrupts air conditioning compressor operation to help provide seamless shifting. Looking at fuel systems, like the Concorde and Intrepid, LHS and 300M use a returnless fuel system. The fuel supply system now uses an onboard refueling vapor recovery, or ORVR system. Designed to prevent fuel vapors from escaping to the atmosphere, the ORVR system consists of a new, smaller diameter filler tube with a tapered design, which guides the filler nozzle into place. A one-way check valve located at the tank inlet that closes when the tank is full, preventing fuel from spitting back out the filler tube. During refueling, when the fuel tank is full, the valve will close, causing pressure to build up in the tank. As a result, the filler nozzle will shut off. Finally, the ORVR system uses a vapor outlet control valve on top of the fuel tank to control vapor flow to the evaporative canister. And speaking of the evaporative canister, notice that it's now mounted directly on the fuel tank. A proportional purge solenoid valve located in the engine compartment controls the flow of vapors from the evaporative canister to the intake manifold for combustion by the engine. In the area of service, removing the fuel tank is easier now because you no longer have to remove the rear suspension crossmember first. The fuel pump assembly consists of the primary fuel filter, the secondary fuel filter, and fuel pressure regulator, which are combined as a unit, a fuel gauge sending unit, and a fuel reservoir, which ensures the pump has a continuous supply of fuel at low fuel levels. Vehicles with the California emissions package are equipped with a leak detection pump, which is used to detect leaks in the evaporative control system. For more information about the leak detection pump, refer to the July 1996 Master Tech. We've already seen some of the changes to emissions control on the LHS and 300M, but other changes have been made to the engine and emission system to ensure that vehicles continue to run as cleanly as possible. Some changes were aimed at ensuring complete combustion and accurate fuel metering. For example, the top piston ring is closer to the piston crown, minimizing the space where the fuel-air mixture can escape complete combustion. Coil on-plug ignition provides more energy for improved combustion than the distributorless ignition system used previously. On 3.2 and 3.5-liter engines, a combined intake air temperature sensor and manifold absolute pressure sensor, or TMAP, provides more accurate temperature readings than the previous intake air temperature sensor. New oxygen sensors located before and after the catalytic converters are less susceptible to damage. A couple changes were aimed at helping the catalytic converter warm up more quickly. Low-mass exhaust manifolds absorb little heat from the exhaust stream, speeding up catalytic converter warm-up. Dual catalytic converters are connected right to the exhaust manifolds. Because of their proximity to the engine, they are able to reach operating temperature faster. The exhaust system has undergone some changes too. First, V-band clamps connect the exhaust manifolds to the catalytic converters and provide effective sealing. Since these clamps cannot be reused, once they're removed, they must be replaced. The stainless steel exhaust system has an aluminized coating for durability as well as appearance. The exhaust pipe joints are connected with band-type clamps that make pipes easier to separate, enhancing serviceability. The LHS and 300M have dual exhaust outlets, and the exhaust tips on the LHS and Intrepid ES are chrome-plated. Looking at steering, power rack and pinion is standard equipment on all of these vehicles. A new steering gear mounting bracket attaches to the body crossmember through two rubber bushings. Steering changes include single bolt pinch clamps replacing jam nuts to retain tie rod adjustment. An auxiliary power steering fluid cooler increases fluid and component longevity. Increased pump capacity guarantees that assist is available even during abrupt maneuvering. The speed-sensitive variable assist power steering, which is standard on the LHS, no longer uses a solenoid control module. Now it's controlled by the BCM. The BCM uses the vehicle speed signal to control the speed proportional steering solenoid, located on the steering rack. The SPS solenoid will then regulate system back pressure in the valve assembly. The suspension on the LHS is similar to that on the Concorde and Intrepid. However, the solenoid will then regulate system back pressure in the valve assembly. The suspension on the LHS is similar to that on the Concorde and Intrepid. However, the McPherson strut front suspension and Chapman strut rear suspension is tuned for a softer ride. The suspension used on the 300M is similar in design to the LHS. However, it's stiffer, giving the vehicle a sportier feel. In the area of brakes, the Tevis Mark 20 ABS four-wheel anti-lock disc brake system is standard equipment on LHS, 300M, Concorde LXI, and Intrepid ES. This system features the Integrated Control Unit, or ICU, which helps simplify the system by combining the hydraulic control unit and controller anti-lock brake. The front brakes now have thicker vented rotors. And on the 300M, the front fascia scoops help to provide additional brake cooling. The rear brake caliper pistons are larger. An electrocoat finish on calipers provides better heat resistance. All disc brake rotors have a dacrymet coating for improved corrosion resistance. Low-speed traction control is standard equipment on the LHS and 300M. The system is basically unchanged, except that now the maximum active speed has been raised to 35 miles per hour. Goodyear tires are used on all vehicles. LHS and 300M now use a standard 17-inch Eagle LS touring tire for responsive cornering and good wet weather traction. Before we look at the exterior feature changes, how about another review question? The connections between the exhaust manifold and catalytic converter are sealed by which of the following? A. Band-type clamps. B. V-band clamps. C. U-bolt clamps. Or D. None of the above. B is the correct answer. V-band clamps are used to connect the exhaust manifolds to the catalytic converters and provide effective sealing. Even customers who are unaware of the many changes under the hood or underneath the new LHS and 300M are sure to be impressed by the sleek styling. But some exterior changes also represent improvements that go beyond appearance. For example, new halogen bulb quad headlamps have an improved beam pattern that provides double the light output on high beams than the previous model. Each headlamp assembly has a bubble level and adjustment screw for headlamp aiming. On LHS, 300M, and Concorde, in order to replace a headlamp bulb or remove the headlamp housing, you'll need to partially remove the fascia. To do this, first remove the rubber grommet from the splash shield to access the fascia fasteners. Then remove the fasteners attaching the fascia to the front fender and splash shield. Next, remove the push pins that attach the fascia to the upper radiator closure panel. Remove the jack screws attaching the headlamp housing to the cross member, and pull the lamp housing forward to access the lamps. To remove the housing, pull the fascia forward and disconnect the wire connector from the back of the lamp sockets. Fog lamps on LHS, 300M, and Intrepid ES have been integrated with the front fascia. Fog lamps can now operate independently of the headlamps when the parking lamps are on. Looking at the windshield, a new windshield wiper system provides quieter operation than in the past. In addition, operation remains stable at higher speeds. A new defroster system contributes to better cold weather performance by clearing frost from the windshield and melting the snow that is pushed down to the base of the windshield by the wipers. The new wiper blades are 3 times stronger and contact the glass evenly for a more uniform wipe. Because of new wiper control logic in the BCM, the wipers will now return to the parked position if the wipers are on when the ignition is turned off. Each hood-mounted washer nozzle has 3 jets for more effective windshield coverage. Finally, the washer fluid level sensor provides a more accurate indication of low fluid. Looking at the rear of the vehicle, gas prop counterbalances allow the deck lid to open with minimal effort. New 4-bar deck lid hinges mount outside of the trunk opening for optimum luggage capacity when the deck lid is closed. The full perimeter tubular weather strip is mounted on a higher flange to prevent water from entering when the deck lid is open. Like the Concorde and Intrepid ES, the LHS and the 300M are equipped with a rear window antenna. A sunroof is available on all models and will be the subject of an upcoming MasterTech program, so be sure to look for it. Now let's take a look at the doors. Laser welded inner panels on the doors reduce the number of components that make up the door. These panels are stronger yet lighter than those used in the past. Next generation door latches provide smooth, quiet operation. In addition, the door ajar switches have been integrated right into the door latch assemblies. Finally, dual power mirrors are standard on all models. In addition, LHS and 300M have heated mirrors and memory mirrors as standard equipment. The memory mirror feature is part of the personalized memory system, which we'll be looking at in the next section. But before we do, how about another review question? When replacing a headlamp bulb, which of the following vehicles requires partial removal of the fascia? A. LHS, B. 300M, C. Concorde, or D. All of the above? The correct answer is D. On LHS, 300M, and Concorde, in order to replace a headlamp bulb or remove the headlamp housing, you'll need to partially remove the fascia. Let's begin our look at the interior by covering electronic security and convenience features, starting with the Remote Keyless Entry System, or RKE. The RKE system is standard equipment on the LHS, 300M, Concorde LX and LXI, and Intrepid ES. A few changes have occurred to the RKE system, beginning with the relocation of the RKE receiver, which now plugs into the BCM. An antenna has been added to the RKE receiver, allowing for an increased operating range of as far as 40 feet. The new key fob now has a red panic button that is clearly labeled. Used to draw attention, pressing the panic button will sound the horn and cause the lights to flash continuously. Also, rolling codes are used, which are coded signals that differ each time the transmitter button is pressed. Rolling codes inhibit thieves from reproducing valid codes. Some customer programmable RKE features include the optional horn chirp and once or twice pressed trunk release. Also, customers can program additional transmitters, up to a total of 4. Another programmable feature that isn't related to the RKE system is the rolling door locks, which is standard equipment on all of these vehicles. With this feature, during acceleration, when the vehicle reaches 15 miles per hour, the doors will lock automatically. This feature is enabled at the factory. However, if the customer prefers, it can be disabled using the procedure outlined in last October's MasterTech program. If you'll recall, we first introduced you to the Sentry key Immobilizer system in August of last year. Offered as standard equipment on the LHS and 300M, this passive theft deterrent system works by immobilizing the vehicle's engine. It works through a specially designed key that is equipped with an integrated circuit chip, and the Sentry Key Immobilizer module, or SKIM, located on the steering column by the ignition key cylinder. If for any reason an invalid key is used, or someone tries to bypass the ignition system, the SKIM will store a diagnostic trouble code and send an invalid key message to the PCM over the PCI bus. The PCM will then disable the fuel system. The Vehicle Theft Alarm, or VTA, is standard equipment on LHS, 300M, and Concorde LXI. In addition, it is available on the Concorde LX and Intrepid ES. Controlled by the BCM, VTA protects the vehicle from theft by monitoring door ajar switches, the ignition circuit, power door lock and unlock circuits, and the deck lid lock sensor for unauthorized entry. Locking the doors with either the power door lock switch or the RKE transmitter automatically arms the VTA system. An indicator LED on top of the instrument panel occurs when the doors are unlocked with either the key or the RKE transmitter. The universal garage door opener has been relocated to the overhead console. The universal transmitter now works with garage door openers that use rolling codes. Looking at the instrument panel, the new design is stiffer and lighter, using foam-in-place construction with a plastic molded retainer and steel reinforcements. Air outlets have been moved from the door trim panels to the outboard area of the instrument panel. The deck lid release button has been moved from the glove box to the instrument panel on the left side of the steering column. Each model has a unique instrument cluster that differs in design, yet they share many of the same features. For example, they all use 4 analog gauges: the speedometer, tachometer, fuel level, and engine coolant temperature. Also, all instrument cluster warning and information indicators are contained within the cluster and easily visible. On LHS, 300M, and Intrepid, the instrument panel is combined with the center console. They are removed from the vehicle as one component. Speaking of which, instrument panel replacement is significantly different from the previous model. You'll need to refer to the service manual for the correct procedure. The LHS and 300M both have an electronic analog clock located in the instrument panel above the central air outlets. The passenger side airbag is a top-mount, seamless design that not only provides improved appearance, but also is less likely to be stolen or tampered with. It uses a liquid fuel inflator for smokeless deployment. As in the past, the airbag control module, or ACM, is located under the center console. The ACM detects impacts by means of an internal sensor. The body control module, or BCM, is now connected directly to the junction block. A base level BCM is on the 300M, Concorde, and Intrepid, while the LHS uses a premium level BCM. You can distinguish between the two by looking at the back of them. The back of the base BCM is gray, while the back of the premium BCM is black. The BCM has been upgraded to support the new PCI bus and has a number of added responsibilities, including exterior lamps, manual HVAC system and system diagnostics, electric rear window defogger, RKE system, automatic headlamps, and customer programmable rolling door locks. In addition, the premium BCM on the LHS now also controls the speed proportional power steering. The new PCI bus, which replaces the CCD bus used previously, was the subject of the November MasterTech program. If you'll recall, the PCI bus uses a single wire rather than the twisted pair used previously. Components that communicate over the bus are the instrument cluster, body control module, powertrain control module, controller anti-lock brake module, the overhead travel information system, Sentry key Immobilizer module, climate control module, transmission control module, airbag control module, memory heated seats and mirror module, CD changer, and all radios except the AM/FM radio with cassette sales code RAS, which is standard equipment on the Concorde and Intrepid. One of the first things you'll notice when looking at the steering wheel is the new four-spoke design. The horn switch has been relocated to the upper center of the steering wheel. New automatic speed control switches positioned between the steering wheel spokes are easier to reach. The driver's side airbag incorporates a new hybrid inflator module that uses compressed argon gas. The steering column, composed of magnesium and aluminum, is lighter in weight and provides enhanced impact energy absorption. Looking at the seats, all of the outboard seating positions use an automatically adjusting unibelt three-point system, as well as height-adjustable shoulder belts. The front seats on the LHS and 300M are heated and are part of the personalized memory system. Speaking of which, the personalized memory system is a feature that is standard on the LHS and available on the 300M. This system allows two drivers to pre-program their individual power seat, power mirror, and radio button settings. The system works with either the RKE transmitters or by switches located on the outboard side of the driver's seat cushion. The memory heated seats and mirror module is located under the driver's seat and is connected to the RKE system through the PCI bus. In addition to operating the personalized memory system, the standalone module also controls the high and low settings for the heated seats. The seat, mirror, and radio settings are programmed into memory using the switches on the seat. After the settings are made, they are entered into module memory with a set button, then either of two numbered buttons. Once the settings are memorized, you can program the RKE transmitter by pressing either the lock or unlock button within 10 seconds after memorizing the preferred settings. For safety purposes, these buttons will not operate while the vehicle is moving. For assistance in servicing the LHS and 300M, a $19.99 service manual supplement will be available. Also, there will be a number of new courses available that cover diagnosing and servicing of these vehicles. Those to look for include LH body electrical, automatic temperature control, sunroof and body mechanical, and engine. In addition, some Level 5 courses will also be available. Now, before we leave, how about one last review question? Which of the following features is not related to the RKE system? A. Horn chirp. B. Rolling door locks. C. Once or twice pressed trunk release. Or D. Rolling codes. The answer is B. One programmable feature that isn't related to the RKE system is the rolling door locks, which is standard on vehicles with power door locks. Well, that concludes our look at the Chrysler LHS and 300M, an update on the Concorde and Intrepid. We hope the information we've given you will be helpful to you in the future. We'll see you next month when we'll be discussing the 24-valve Cummins diesel engine.